Hello, I'm Ruiz from the EDCI 3301 104 class. I'm here to try to explain the area of a circle. Now, first of all, math can sometimes be a tough subject for people to understand, much less to teach. Um, Due to it having so many numbers or equations, it sometimes can be a disillusion for people to try to understand math. However, there could be an easier explanation in order to try to find the area of a circle. That's going to be our goal, finding the area of a circle. Now, for this lesson, the students would need to have previously known how to find the circumference of a circle. In case you don't know, I'm just going to write it. The circumference of a circle is found by multiplying the radius times pi times 2. Or you can also say that circumference is the diameter times pi. But in order to keep things simple, we're just gonna use the radius instead of the diameter. Now, the radius of a circle is a line that goes from the middle of a circle to one side, while the diameter is that same line multiplied by 2, going from side to side on the circle. The way that this formula works is that pi is already a set variable that we have with circles. So by multiplying it by the diameter or by the radius times 2, we find how much length is used around the circle. Now, in order for students to find the area, we could use a concept that they already know. You could give circle paper cutouts to the students for them to try to fold in half and then cut. If you could tell them to cut in half and then cut them into 4 pieces, you could find the students making a figure like this. Maybe a little more wide. A figure like this. Nope. I'm a math teacher, not an art teacher. A figure like this. This is 1/4 of a circle, and if the students have 4 pieces, you could have them draw something. You could have them make something like this. 1, 2, 3, 4. Now this weird figure might not resemble anything to the students, and this is the point where you ask them if this made it easier for them to find the area. Perhaps they already know it. Most of the time it's not gonna work, and maybe you could ask them to cut each one of the pieces in half. Now, I already have pre-cut pieces of the circle that were divided into 8. So 1, 2, 3, 4, 5, 6, 7, 8. Now these pieces came from a circle exactly just like this one. And if you put them like this, it could be easier for the students to see how it resembles a rectangle. Now, finding the area of a rectangle, let's just draw it here. The area of a rectangle can be found by multiplying the length times the width of a rectangle. Now, you could tell the students to perhaps draw a rectangle going around, or even a parallelogram if the students cannot recognize it. This works because if you kept infinitely cutting the pieces in half, you would eventually reach a perfect rectangle with infinite number of circles pieces going inside of it. Let's just erase that. Now let's bring this circle back. Now we know that if we know that the radius is just one side of these triangles, which in reality is the center of the circle going to the outer radius of the circle, to the outer diameter of the circle, we could then say that this one equals to 1 radius. For the sake of this argument, let's say that the radius is just 1. That would also mean that the radius on this side is 1, even though it doesn't really matter. Now, here's a part that can confuse a few students. This side of the rectangle comes from the circumference of the circle. So let's just draw here and here. However, students need to realize, to understand, that it is not really the circumference of a circle that is here. Instead, it is half of it, because this side is only half of the bases of the triangles that have been cut out. You see, 1, 1, 1, 1, 1, 1, 1, 1, and so on. For this to work, you will need to have a circumference divided by 2, circumference divided by 2. And let's just try to work it out like so. It is half, more or less. Now that we know this, and we know that the area of a rectangle is found by multiplying the length and the width, we could change it to be that the area of a circle, that's right here, area of a circle, is equals to still the length and the width. However, in this case, one side is going to be the radius, and the other side is going to be half of a circumference. So circumference divided by 2. Now, students might still not be able to understand this, and that is okay. We need to replace that circumference for its pieces, meaning that we could erase that and write r times pi times 2. Let's complete the line. Now, here is where the magic happens, because we have a 2 at the top of this division and a 2 at the bottom of this division. They could cancel out, and we can simply erase them, since 2 divided by 2 it just equals to 1, and multiplying by 1 gives the same result. So we're left with area equals to radius times pi. Now here is another procedure that we can use sum up. Since radius times radius, that's basically radius squared, times pi just comes down. Now this is your equation to find the area of a circle. And all we needed the students to know was to understand the circumference of a circle, and a more basic one to understand how to find the area of a rectangle. Using these simple pieces, we could help them understand. In order to give an assignment related to this, you could use, first of all, have them do their own cut circle on their own paper and grade that as an activity for them to understand, but also give them an activity which is asking for several areas of different circles. For example, we had said that the radius of this circle is equal to 1 unit. So for this example, we could simply say that the area of the circle is equal to radius, which is 1 squared times pi. Now 1 times 1 is still 1 times pi, let's say it's 3.14, and the area of a circle is going to be 3.14 and so on units squared, whichever unit it was. Now that is how you explain the area of a circle to students, and all they need to know is the circumference and the area of a rectangle. That is it, and that is an easy way for them to understand. Thank you for your time.